Hello, I'm Juantomás García. I am, let me check this. I am the data solution manager from OpenSistemas, and OpenSistemas is a small company in Spain. We are very specialists in big data projects, and usually we use as our name tell open system. We started 15 years ago, and also I am the former president of the Spalinus. Spalinus was a very important local research group in Spain, and I can say in the south of Europe we did a lot of projects in Spain. Even we had a couple of laws in the parliament. We are very proud of this. And also I am the author of the La Pastilla Roja. This was the first Spanish book about free software. This book is very funny because the La Pastilla Roja in English is the red pill. Did you remember the Matrix movie? You need to choose between two pills, and we choose this name because the red one was the good one. Okay, and it's funny because the book has a picture of a red pill, and everybody that talk with me tell me about, and this book is about drugs. No, it's about free software. And okay, I understand, but what is your favorite drug? I say the red pills, but it's so funny. I recommend you to roast a book because you got friends in the bars and the clubs with little sport. Today we had this menu. We talk a little about the history of Kappa Architecture. After that, we take a look about the Lambda architecture and say what is the pros and cons about Lambda. And after that, we take a look in the Kappa architecture. And the final one will be about how we use in OpenSistemas Kappa architecture with some real use case. Well, a little context about Kappa architecture. You know this guy? This guy is J. Krebs. Everybody knows J. Krebs? Okay. J. Krebs wrote this post in O'Reilly Radar, and there is the very first mention about Kappa architecture. And this was very important because in July 2014 was the first mention, and when J. Krebs started to talk about Kappa architecture, it's funny because here he put a sentence saying something like, this is the H2 sample that I think is not hard or not worth to merit to a Greek letter. Okay, I think merit the Greek letter. Well, J. Krebs was involved in a lot of projects, but I think this post or DCC is very important to understand the story of the streaming data. I usually say that there is two kinds of engineers. The engineers that read the post and the rest that never think about the thing. You have the link to read the post if you didn't, and this post is about 30 or 35 scrolls. It's a long post, but worth to take a look. There is a version of this book is with a pretty picture. It's almost the same version of the original post. Okay, and the thing about the post is that JCRES starting to thinking about what if all the information is created like a log. Okay, this is the post. What about if you think about the clickstream of the one we said? It's very easy to think it's a log because every click, every page is reporting in a file, and you have a lot of information. But what happens if you start thinking about all the information that is produced in a system? You can work with this information in the way it's a log. That is the book. That is the thing. Perhaps it's so simple, but when you are starting to think about everything is a log and everything can be streaming or data streaming, the way you think about the information change. Well, JCRES was working in this project. Perhaps you know about a couple of them. The most famous perhaps is Apache Kafka. Apache Sansa is like a Storm or Spark. Voldemort, I don't know what it's about, or Azkaban. Now he leave LinkedIn and is the co-founder and CEO of Confluent. Okay, and it's funny because if you see this name, you can. This is a view from a data scientist or from a person that is working with data. When I see this list, I say, hey, I got the two last book JCRES read, and as you see was the book from Kafka and Harry Potter. That just is a little funny question, and you can discover what will be the next book. Okay, so take a look in the Lambda architecture. Everything here know about the Lambda architecture. This is very standard. I will talk a little about this, but you have a very good entry in the Wikipedia, so you can read more about this. But this is a very classic approach to how manage the information in the big data or data project. Okay. There is two parts. Let me. Oh. He conseguido. Can you maximize again the presentation? Okay. Well, there is two parts. This is very classic. You have a batch part and another speed part, speed layer with the information that is created in real time or from the data stream. You have, when you are serving the information, you merge the info from the speed layer and the batch layer. Almost this is more or less a classical view of how to work with Lambda architecture. The part of the batch layer is usual is Hadoop. Are you using MassReduce and something like? The speed layer can be stored, can be stored as in some way in Hadoop, okay? And there, this part, in this part, there is in the batch layer there is interesting points like the information in the batch layer, the information the data you store as in Hadoop file system or whatever are immutable. You can pre-compute or having batch views for speed, but in this part is you are thinking in batch. At the end, it's not interactive and it's a very classic approach. Okay, the server line are only merging the information, and the speed layer trying to integrate this information. I will. Well, here there is some technologies. I don't want to spend so many time on how can be organized the Lambda architecture, okay? But there is a lot of things, but I will go directly to, here there is interesting thing. Well, when you are working with Lambda architecture, you have a lot of things that are usual. My favorite one is the code will change everything, and this is a problem because if you have an stable platform, you have a project that are working, and this is the perfect state of your project. But we know that the code, because there is error, because there is new feature, we need to change every week, every month, or every time. Okay, so another thing that is important in the Lambda architecture and is a problem is that you are working with information in two layers that are very, very different. So you have MapReduce in one layer, you have Stone or whatever in another layer. This two systems need to produce the same information, and here is when starting the nightmare. You need to debug this, to maintain this. In the case of the layer of batch, you can have a lot of technologies, different debugging ways. And with this, JCRED is starting to make a proposal. How to simplify this and have a more simple project. And it's so easy. The proposal of the JCRED is, well, we will use one streaming data platform. In the case of the LinkedIn and the JCRED things was Kafka. How many of you know Kafka? It's a great project. Eh? I really love Kafka and really simplify my life. After a couple of the slides, we will see some examples. But what happens if you are using Kafka to get all the information? And remember that JCRED said that all the information can be streaming, even a database update or new insert can be streaming to Kafka. In addition, and as you know a little of Kafka, you can maintain, it's not only a messages broker, it's Kafka can retain the information. You can configure Kafka to say, hey, I wanted to maintain in the bus some number of terabytes, and this is not a problem for Kafka. okay? So we had this lot of, we had this streaming data, and now we can, if we wanted to debug, if we wanted to make a new version of your program or the processes that are working with information, you can start a second instance, a second producer, and start testing and debugging the testing process. Okay, let me show this schema. It's something like you have the Kafka cluster. You can have running a JOT version that is the working in production version. You can transformation or aggregation the data and writing in an output table, and your application is consuming this information with queries against this table. The thing about Kafka is if you wanted to test or make a new version or new feature, you can start a consumer, like here, reading the same information that the old version and writing another table to check if the changes you are making work or not. Okay, we can see this better in a next slide. Okay, and this is very flexible. If you think about the Lambda schema I showed before. Okay, so there's important things. The first one is you didn't have two different layers, only just got one, and you only have one code to maintain. This is very important. Another thing you can do it is to mirror the information in not only maintaining in the Kafka system. There is a lot of flexibility how to work. I think I will. Okay, I will show this slide before. This is the state, more or less, and a simple version of how LinkedIn working. But this is a classic view of how information system work. You have in the upper side application and services that produce information in traditional relational databases, in a lot of systems. You can put even in messages brokers, and you have a lot of relation with this. If you see this part like this is the way, the place where the business people starting requesting feature. Okay, the problem is when you have only one request, well, it's more or less easy to draw or to get the information from the relational database, but starting to appear a lot of little things like this, that is a CSV dump, files in STP servers, and starting to have a complete mess of how the information flow out through the organization. Okay, the problem, there is more problem because when the people request information to make a model reports or whatever, or try to work with the information, the people from IT, and I think it's legal to claim this, starting to say, hey, you cannot make 1,000 SQL queries against my database. I put all the information in these files, and you work out of my production database, because if not, you make a DOS of the system. So when every time the business people make a request, or the analytics people make a request, this graph puts a lot of arrows to try to work with the information. The proposal of the Kappa architecture is trying to make something like this. This is an implementation from or using Kappa architecture, and we had the traditional project and applications storing information in his system, very agnostic. But the funny thing here is that this application, or even directly, the information flow through the stream data platform. Okay, so the first very important thing is you only need to implement a way to export the information to the stream data platform, and you resolve and you forget about how the information will be used. Okay, this is the very first one. And if you are thinking that this piece is Kafka, in the case of Kafka, in the last version, you had a piece of code or piece of service that is I didn't remember the name. I think it's Kappa Connect. Even you didn't need to rewrite the application to inject information here. Kafka has a little program that can get the information without down the databases. This part is important. The second funny thing about the Kappa architecture is there are producers, but you can start in every request from business. Every time you need to put additional information, make aggregation of the data, you can make a little application, a little project that is reading this information in a kind of topic, and you can working with this. Now it's very easy to don't need IT hours to start a project. If you know what is the schema of your data stream platform, you can start a project very fast. If you know what is this organization of the information, you can start an application like dashboard, getting a simple analytics in a simple way. Okay, even you can in real time take decision like I will copy this part to make some tests, or I will re-inject the information with the additional data and starting new consumer that will work with this last version of the information. A case for this can be Twitter. As you know, when you send a Twitter, you receive in the Twitter servers, you receive who sent the Twitter, the text of the Twitter are almost nothing. When if you are using Arquitectura Kappa, you can create one consumer that put the rest of the information. If you're working with the Twitter API, you will see when you recover one Twitter, you got a lot of information about a JSON with almost 100 fields or something like this, from the real name of the person that wrote the Twitter, the picture, the website, his home websites and whatever. You can do something like this, only creating a consumer that put this information, enrichment this information, and after that ingest again in the stream data platform. Another thing you can do it is saving this information in Hadoop or in a pre-cooked way, okay, or in traditional file systems like Teradata. But I wanted to say this again. This is very, very clear if you compare with the previous state of how to manage all this information. Okay, so Kappa Architecture didn't make any recommendation about the words, what the technologies you need to use. In our case, in OpenSistemas, we use Kafka, like LinkedIn People or Confluent.io, as a stream data platform. I think it's something that you didn't start working with Kafka, I recommend you spend a couple of hours because for me or for my company, it's one of the key technologies. Instead of Sansa, we are using Spark streaming. There is more alternatives like Stone, like Apache Flink, but we feel so comfortable with Spark streaming, and the kind of project we are doing really didn't need real-time features, so it's perfect for that. And for the rest of the module we use the rest of the components of Spark as an analytic engine and the rest of things, machine learning and whatever. Well, this is important. We think that a Kappa architecture for us is a design pattern. When you start thinking that the information is a kind of love, you are starting thinking about data streaming and think about the way to solve the problems in the way Kappa architecture is defined. We use like a design pattern. Only, you know, the joke that a hammer only see nails is a kind of thing. Even for big projects or small projects, we started thinking perhaps we can organize the flow of information in the way of Kappa architecture and work. And we have a time to market very fast thanks to that. Another thing, well, I talked about of the size of the project. It's very important because we will see some projects. We will start with this project. That was the first project I did with Spark. I did this project, I think 2 years ago. The problem with Telefónica, for the people who didn't know, is the Spanish telco. They have a product that is called management security system, and this project got a lot of information from different sources to try to manage the security system. Okay, we use Kappa architecture for calculate real-time KPIs and SLAs. Okay, before we started using in this project Kappa architecture, we have the same mess as LinkedIn has, and We need to put order in all these sources. We have sources for OSINT system, for the status of lots of device, not only server, firewall, even printing. We are talking about not too much big data. It's about 4 million status or item a day. But the problem was a lot of different sources, CSV files, FTP server, even when this information was replicated, that doesn't work fine. Well, that was a terrible mess to work with this. Even the previous version of the system was making with Pentaho, and Pentaho needs to calculate this information, the KPIs and the LSAs. For the KPIs of the day, 28 hours. Okay, and if you recalculate the KPIs, the result was different. It was a previous, a terrific, really was a really mess. Try to make working this project. So the first thing was to try to simplify the data flow. And when you are talking about a project with a company of this size, it's a lot of department, a lot of people that have procedures that you need to talk with a lot of IT people. But we got that every piece of information was writing in Kafka, and the thing started working. Okay, so as MEPP and massive parallel processing, we use Cassandra DB in this case. I'm not a very big fan of Cassandra DB. Cassandra DB is very fast, it's very stable, you can go through a lot of things per second. But when you are working with Cassandra, you need to define the information of the data schema in the same way you will make the queries. You know, so it's not the best one if you want it a flexible SQL or try to make any kind of different query that you know design the schema for Cassandra DB. The good thing of this project was that we got in 2 months we do this is analytic in just 3 minutes. Okay, from 28 hours to 3 minutes, and when we repeat the process, the data was the same. I know that this is trivial, but starting working very fast. This is a kind of big one project. One of my favorite is this IoT. I put this because the marketing guy said, no, put IoT because this is trending, but I will explain you what is this. This is a really smart project about you know what is OBD? OBD is on board device, and it's a little device that you put in your car, in the car booth. Okay, so you get a lot of information from your car. What is the pressure in the brake, or the speed, or what is the capacity, well, the level of your gas, and a lot of information. Okay, so our client make a little product and put in a lot of cars this device, and using this device gets a lot of information, and they can make a lot of little things. Okay, when we started doing this project was a kind of proof of concept, so and we didn't know about Kappa Architecture, so we started making something very classic. we make an Android and iPhone app, okay? The information was acquired by Bluetooth, so we transmit this information to REST API, store as in MySQL, pretty standard. But the problem was when the number of the users started sending information. Okay, MySQL had not too much record, but a couple of hundreds of record. So starting having problems with the inserts and this kind of thing. Forget when you need to make a query and was a little complex with a join or making a full scan query. Okay, so we architecture everything and make some little changes. The first one was to start a Kafka server, starting not saving in MySQL directly. Instead, we are starting to put the inserts in a JSON format into the Kafka flow, okay, and make and save. We build a small consumer to save MySQL. That was the same thing with the same problems, but we starting. We put a very important change that was including the Kafka data stream before the operation. Okay, the next step we did to solve the problem was starting to create a new consumer. That consumer was only a new getting the topic with the inserts, with the data from the OBD, and we're starting to save in Elasticsearch. Okay, so if you take a look, we can able to very fast and done it without almost any change. We have in production the old way to store the information, and we can start with the same information to save this data in another store. In this case, Elasticsearch. Okay, so when we was pretty sure that Elasticsearch worked fine, that there is no problem with this new implementation, we stopped all MySQL. Well, we migrate the information and everything, and the thing starting working with the new version almost without Pine. Okay, so the next part was when our client started making analytics, and that was funny because you think in a normal project, you think, okay, tell me what you want to do, and I will implement. It's so easy. The first thing that I wanted to implement in this project is when we have a lot of information from the users, and we know a couple of data information, like what is the level of the gas in your car. So when you almost empty your gas, we wanted to send an alarm or a message or notification to the user and say, hey, we have an offer for you for this company, let's resort or whatever, and we know you are a normal user of the the other companies. So we have a bonus for you for €5 or whatever. But this is a very little sequel that spends almost 10 or 15 seconds per user. So you need to do this in real time. So we are able to design this query so easy, but you cannot do this in real time because remember the car is moving and the car needs to, and we need to recommend a gas station very near of you and propose a new route for you. But that was completely impossible. So at the end, we had Spark working and reading from the streaming, and we was able to have almost all the information we need to make this query in memory with Spark, with classic Spark. We have a job with Spark streaming, reading the actual position and actual level of gas in the car, and we was able in memory to make these queries without affecting Elasticsearch and the rest of the users of the system, and we was able to send this notification to the user, and almost in milliseconds, in block, every 5 seconds, because that's not in real time. Almost every 5 seconds is good enough. But it was so simple without touching any part of the infrastructure, just making this consumer, testing it, even used Kafka to send the notification and have a consumer that delivered this documentation, this notification, and this was so easy to implement, so easy to more or less every project has his tower and his time, but the complete architecture was very easy. We can have a new dashboard because the people from business tell us that they need to have a dashboard to check how is the system. Was so easy to get all the information for the Kafka booth and created this dashboard. By the way, another thing we use Apache Spark, and this is very important, is about Scala. How many people of you use Scala? Very well. And Java? And you like it? No, I think I cannot write more code for Java anymore. I mean, I can say that Java sucks, but this is not too political correct. So it's Java guys, you need to take a look to Scala seriously. It's another thing because I am so happy with Kafka, with Spark, with Scala, because my time to market, my time to solve the problem is a different way before. I didn't remember the thing I need to do before Scala and Apache Spark. That's why I'm so happy. This is a very classic data clickstream project. It's the same thing, the same architecture. As you see, all the time I am doing the same thing. Start Kafka, getting the information directly through the IPA or even pushing for the data. And after that, I put an Spark, a little code in Scala, and everything is happy. And this is a more complicated, but it's all again the same pattern, and that's all. I don't know if you have any question. There is a very important part. Here is my email and my Twitter. Every talk I I gave has a life guarantee as it sounds. I mean, if you didn't want it to make any question now, you have the rest of my life to make this question. I'm not kidding.
So we probably have time for some quick questions, as well as obviously the rest of your life, so which is a very generous offer. Any questions? I think everyone now feels they have years to ask the question, so they don't need to ask it now.
And remember, I work a lot with data, and at the 100th lecture or something like, nobody asks for a question, so I can offer this because it's so cheap. This is the trick. It's okay. I will stay around here, and thank you very much for.
Thank you.
For the opportunity.